me record. So under this topic, we are going to look at basic object-oriented concepts and how Python programming, we define simple classes and the methods. So that's what our topic for today is. So having said that, let's start. Now, object orientation is a common program paradigm, a way of developing programs. And the key concept that we are going to discuss under this is what you call classes and objects. So when we want to find a solution to problems, so we basically create classes and objects, and we define object interactions, and that's how we develop solutions in object-oriented programming. Now, when we talk about different objects, now, for example, let's say we want to represent university information system. So in the university information system, we want to keep track of, let's say, lecturer information. We can keep track of student information and so on. So what we can do is we can create what we call lecturer classes, student classes, and so on, which then they will, the classes will act as kind of a templates. And then let's say if you want to create particular, if you want to represent particular lecturer, then we can create what we call instance of a class, right? So basically, as we can see, the class basically it represent what is available in the outside world. We can provide a consistent view of the objects that we can use them as instance of this class. So when we define classes, we have things called variables. So we call instance variables, also data. Like in my example, if you take lecturer class, the lecturer's name, their address, their specialty, those could be its instance variables. And then the classes may have methods. For example, lecturers could teach, they can evaluate, they can prepare exams. So these are known as kind of a methods, right? So we will also say they are the member functions which object can execute. Right. Now, so to represent the classes, usually there are different representations. So one common representation for object-oriented programming is uses of what we call class diagrams. In class diagram is a kind of a graphical representation like ER diagrams, where we can represent different classes and we can represent their interactions. Now, when we say a class, so you can see a couple of things. You can find the name of the class. For example, in this slide, you will see there's a credit card class. So the first row, you can see the name of the class, which is credit card. Then you will have instance variables or the data members. So you can see in the credit card, we have defined 5 instance variables: customer name, in short, we say C name; bank name, in short, we say B name. Then there should be an account which prefer the credit card. Then there should be a limit, and there'll be a balance. That is the second row. In third row, we can have a set of methods. Now, for example, usually we say getters and setters. In here, we have some methods to get information, like getting customer details, getting bank details. And also you can see getting balance. Similarly, you can make purchases, then you can make payments to the cards. So you can see, so class diagram represent these different information in a graphical environment like this. Now let's look at some more examples. Now in this one, you will see we have instance variable for let's say a person. We can have name, age, and address. And then you can also have methods like walking, talking, breathing, and running. Similarly, you have email. In email, we can have variables like recipient list, subject, and body. You can also have set of methods like adding attachment, sending an email, and so on. Third one, if you take car, you can find year, model, and mileage could represent the instance variables in a car. And methods could be things like accelerate, brake, and so on. So now let's look at how the object creation process. Now I told you in object-oriented programming, we start with what we call a template or a class. Now this class is a general representation, right? So it's a general representation. But when you say object, there are particular instances. Okay, there could be a same car model, but you know, when you have a particular instance level, you can have like different colors, for example. So starting from class to getting object, we will have what we call constructor. So in constructor, what it does basically, there'll be a sequence of actions which constructor can construct an object of car using car class. Right, now let's see in Python, how do you define a class? Now, the first thing that we would like to know is there's a keyword. We should understand the keyword called self. In self, that you can use, for example, in any class, you can see there could be many different instances, and you have to have your own set of instance variable. Therefore, whenever you want to store instances as its own instance variable to reflect its current state. So self is a keyword that we can use to indicate which method is actually invoked. Right. Now let me explain this first. So in this particular example, I will open up Google Colab. Right. So let me use our Colab environment and let me explain each of these commands. Now, in this particular case, you can see a representation of a class. Here we have one variable we call name, and there are two methods, getting a student name and then study method. Now let's look at how to create classes, right? So today we are going to have session number 7. So let's start with the session number 7. Session number 7. And today is 9. Right. Okay. And then, okay, let's start. Now, creating a class is very simple in Python. We can say class, that is a keyword we use to create a class with the name of the class. So in this particular case, it's student. right? So we can see here we have a student class. Right. So these three single quotes represent we call documentation string. For the time being, you can think it as a kind of a comment. Now we discussed two things. We have what we call the instances. We have instances, and then we have methods, right? Now, when we talk about the instances, right? Before we use any, methods as such, we want to create what we call initializing this. Now, to do that, right? What we want is we can use a constructor. So creating a constructor is usually like this. So we are going to create a function. So we are defining a function called init. So it starts with two underscores, init, and again two underscores. And then we will have self keyword. I will explain what this is. And some input, right? Now, for example, we are going to create a student class. Let's say we assume that we want to get the student's name. So I will say student name, right? Okay. So now that we want to store the internally, the variable name for the class is name. So we represent it as self.name. And then we will get a student name outside, right? So like this. Then we can define what we call the methods. Okay, but before that, before I explain the two methods, please raise your hand if you have finished up to this point. Right, now let's create the methods. The first method, we are going to get what we call getters sometimes. We are going to define a function called get name. And self keyword is always there. And then we will say, okay, what we need is we want to get the name. So when you are going to refer the same object, right, we can use a self keyword here, which will return the name. Similarly, let's have the next one as well. So in this one, let's say def study. We have self. And then let's return study. Right. And that's all. With that, we actually finish creating the class. Okay, let me run this. Actually, we have now defined a student class with one instance variable that is name, and then two methods. The next one, let's see how we create what we call objects from this student class. So for that, I will take another code window. So let's try to create a student object. So the first one is, let's say, let me name this student as S1, and I'm calling student class. You have to provide a student name. So let's say Saman. Now what happens when you create like this? This will pass down here, right? The initialization. The student name we have given Saman, it will assign it to student name. And internally, that object, the variable name is assigned with Saman, right? So when you want to get name, for example, you can say S1 dot get name. So you will get name of the student. So I will use with the print. Let's say print S1 get name. Now let me run. And you will see that I will get it as a Saman, because here we have assigned Saman, it will assign it to the name. And then when you say get name, you are basically returning the variable name. Right, next, similarly, you can call the other method S1 dot, let's say, study method. And what happens? It just outcome what is inside this method, that is studying. Finished? Please indicate if you have finished by raising your hands, then I can move to the next one. Okay, here is a small exercise. I want you to create a class called car with three instance variables and two methods. And I have given you some values as well. So let's create a class and let's share the answer in the chat. So as we did from the previous one, we have to start creating a class. And this particular case, we have to say, okay, class car. And then during the initialization, earlier we assign only the name, but this time we have three more variables. So within the init, you have to have the three variables to assign. And then you can have two simple methods to say accelerate and brake. Right, we can see here, we define a car class, and this is initializing. Right, now here we have first initialize it. We get three values, year, model, and mileage. And whatever the value that we provide will be stored under the instance variable year, model, and mileage. Then we define two methods, accelerate and brake, which returns the message accelerating and brake. So for example, we can click, say, car1 dot accelerate, which will return the accelerate. So I missed entering self here. So I have to type self, both here also self. Right now you can see it's output in the message, right? Accelerate. So you can see now once you create the class, we can create our own objects. So this is the first car. Similar to that, you can create the second class as well. Right. Let's create a more lengthy one, right? If you have finished up to this point, please raise your hands. So we will go back to our original example credit card, and let's create a complete example using object orientation. Similar to previous example, now let's create a credit card. And in this one, I have like five variables to hold: customer name, bank name, account details, limit, and balance. And we have a set of methods: get customer to get the customer name, get bank, get the bank details, get balance to get the balance. Purchase is to use credit card. And the last one is make payment to settle the credit card balance. Okay, let's give it a try, and then I will discuss the complete answer. So let's create a credit card class. So you can say class credit card. Now in initialization, you can actually get customer name, bank name, account number, and credit limit. You don't have to get the balance, because balance we know when you create a credit card, balance will be zero. Okay, right. Can you create the initialization, the very first function, which initialize the variables? And can you share the code in the chat? Right. The mistake I made here is I put C name and B name. And I actually confused with that, right? So this should be not bank, it should be B name. So it says credit card balance is 0 and BOC. Okay. Things like, okay, right. Now this is initial one, but now you have to create other functionality as well. This is how to create it, but let's create couple of ideas. Now, for example, here we have, sorry, here we have a class diagram. We initialize the value. Now previously we directly tried to access the instance variable, but the best way would be like we will have a set of method, and through the methods we can get those. So usually to do that, we have to create, like, for example, when you say get customer, you basically return CNAME, right? And then you can directly use this. Okay, I will show you one, and then maybe then you can implement the other two. Okay, so now let's I'm going to create get customer, and then you can use other two. Right, so let me see. I'm going to get this. So what I'm going to do is I'm going to create another method. So def, let's say get custom. Self keyword is always used, which will refer the same object. And what we need to do is we need to return self dot CNAME, right? This is what the name we are going to use. So now what I want to highlight it, instead of trying to access directly the name like this, the best thing would be, right? You use the method, right? You use the method. So the method now here we can say, instead of CC CNAME, we discuss or we get the get customer method, right? Like this. So that is the best way to do. So which means I want you to update the last two as well. Right now, I will comment these two out because I want you to fix these two, right? Now, when I run this time, we'll get the same value, but now we are not going to directly access what is inside the class, but through this method. Okay, can you complete the next two and share me the code? So next, create get bank and get balance. Those who are finished, you can think of implementing purchase. That means using the credit card. Yes, try the next one. Okay, so what we want to do here is to create a method for get bank and get balance. So here I will create get bank, and what we need to return is self dot bank. Sorry, we have to say B name, right? Here we have bank name. So what we need is B name, bank name. Similarly, Let's get balance. And in this case, we have to get balance. Right. That's what we need to do. And once you do that, we can replace, we can change instead of directly accessing. We can say, okay, cc dot get back. And here we can say get balance. So let me run. First, I want to complete this. So I'm waiting to execute. And then let's run this now. So we'll get the answers. Okay, now that you have created these methods, the next one I want you to think about implementing the purchase, right? So in the purchase mean you are going to purchase for some price. So how do you implement this, right? Couple of things you have to think about this because there's a limit which you should not exceed. And then you have already a balance. And then there's a price as well. So already there's a balance. Let's say that there's a credit limit of, let's say 50,000. And if you say balance is 20,000, that means out of 50,000, you have already spent, 20,000. So the balance will be 20,000. So which means the price that you are going to purchase should be less than the difference, right? You cannot exceed. So few things that you have to think about, like purchasing. So let's say I told you the credit limit is 50,000 and let's say balance is 20,000. What is left is 30,000, right? So if you try to purchase something greater than 30,000, it should not allowed, right? So remember that. So let's start the purchasing. So we want to create purchasing here. So the method is, we can say, okay, def, you can have purchase self dot price, right? Because you need to know the price. Now the problem is, now when you make a purchase, you have to update the balance. So updating a balance could be done like this. So you get what is the current balance and you enter price. This is perfectly all right. Now the problem is, if the price is greater than what is the limit, you cannot do that. Now, like I said earlier, if you have the limit 50,000 and you have balance 20,000, the price, the maximum should be 30,000, right? You can't go beyond that. So that means you have to check that. So let's add a selection here. So what you need to check is if self dot limit, you know, you have a limit, and we have to make sure that, right, the current balance and the price should be less than or equal to the limit. If that is the case, yes, of course, you can use, this one, right? And it's a success. So let's return to else. We have to say a return false. So what happens now? Now, if you go here, you can see there's a credit card balance 0, which we have not done. So let's make a purchase. So making a purchase meaning cc dot purchase, let's say 20,000. Now let me check the new credit card balance. Let me run. Okay, I think I have to rerun this one first. Okay, done. Now we will run. So what happens? You see, we started here, there's no balance, and then we make a purchase of 20,000. So now credit card balance has gone up to 20,000. Let's make it another purchase. Let's say 15,000, right? And I'm going to, check the balance again. So if I do this and if I rerun, okay, now after 20,000, we made another purchase 15,000. Credit card balance becomes 35,000. Now, what if you're trying to purchase, let's say 40,000? What do you think? Will that be allowed? Should not, isn't it? So if you rerun this, and this time you will say, okay, you are trying to spend 40,000, and then since you don't have enough balance, it will not be added here, right? So that's about how to define the purchasing. Right. Last one. Can you make the payment? Right. We need to create making the payment, which means, okay, right now we have a balance of 35,000. So just pay some amount which should reduce the balance. If you finish up to this point, can you please raise your hands? Okay, so in this one, I would like to discuss how to make a payment. Currently now, when you're making a purchase, it will check whether the balance is sufficient, and then only it'll added that purchase to the balance. Otherwise, it's like a refusal. The make payment, on the other hand, should reduce the balance amount, isn't it? So you are, let's say you are paying 10,000, right? So how do you find the balance? Then you can say, okay, self balance should be self balance, subtract the amount. That's all. So let me run this. Now let's make a payment, right? So the right now cc.make payment, let's say 10,000. So what should happen to the current balance? Currently, what we have is 35,000. When you pay 10,000, ideally we should get 25,000, isn't it? So when I run this, now you can observe that, okay, the credit card balance last point will be reduced by 10,000. So we discussed the basic object-oriented principles. We learn how to create a class and also initialization, which means we want to initialize the variables, and then we have a set of methods. And now after that, we also discuss by creating a one credit card and getting the information about the credit card, and also we simulate. So we have done a couple of purchases, and also like we try to make the payment and see whether it's working. Right. If you finish up to this point, please let me know, and then we'll move on to the next topic. to the next one. Right. Under the next one, we are going to work on the numerical Python or NumPy. So numerical Python is one of the libraries available in Python, extensive use for representation of vectors and matrices. If you go to numpy.org, so you can find information on the usage of this library, and you can also see there are a lot of ecosystem around this NumPy library. For example, based on this library, there are many other libraries were developed or depend on this. For example, you can see there are suggested libraries for quantum computing, statistical computing, signal processing, image processing, and so on. Almost all these has dependency on numerical Python library. And particularly if you go to data science as well as machine learning, which is quite popular nowadays, and also visualization. So most of the libraries are heavily depend on the representation of numerical Python. So in this part, we'll discuss the basic ideas of how we can represent vectors and matrices, as well as how we could generate, because data generation is another important one. How can we generate vectors and matrices in Python? So let's start. So as we can see, we can define matrices and vectors, and we can use NumPy, which is stand for Numerical Python package. Now, the very first thing is, what is the difference between Numerical Python as well as the lists? Because they are also data structures, and let's try to understand the difference. So I'm going to get, okay, right. Let me take a code window. Now, first one, under the data structures, we discuss the representation of lists. For example, let me create a list called test1. And let's have some numbers. Let's say 1, 2, 3. It's a very simple, list. So if you check the type of test1, and when you run, you will see that this is the list data structure. Now, numerical Python is also quite the same. So only thing is you have to first import it as NumPy, and we can shorten as NP. Right? We skip NumPy, we shorten as NP. And let me create test2. So in this one, we will use NumPy array method, and then we will use the list of numbers. Now, originally Python list, you can have mixed data types. But when you define as NumPy array, it should be a single type, right? So make a note of that, and let's print type test2. So when you do that, you will see that when you're using numerical Python library, so the class or the data type of test2 is represented as numerical Python n-dimensional. Numerical Python n-dimensional. Okay, so let's move to the next one. So in this part, I'm going to discuss how we could create vectors or one-dimensional arrays in numerical Python, right? So in this particular case, let's create a simple vector. I'm going to get a import numpy as np. This is the first one because we want to use this library for that. And then the very first one we are going to do, we'll create a row vector. So in the row vector, let's say it's A, we will use np.array method. Within that, we will have a list of numbers 1, 2, 4, and 5. Right. Now let's look at what A is. And let's try to first print A. So this is in-dimensional array, but this will create a vector. So when you say print A, you don't see any difference. It might look like a list of numbers. But then again, when you say type A, you will see that it's actually not a list, but an in-dimensional array. So printing A will not change, and you can see, right? So what we could do is I can say print type A. So first we print A. It looks like a list, but when you check the type, and you should now notice that this is n-dimensional array. Right, it says class numerical Python n-dimensional array. Now, since we have defined as an n-dimensional array, there are some variables that we can use. Now, for example, we can get things like a shape, and shape will tell you like, number of rows and columns. And then you will see the next is size. And earlier when we say shape, we have 4, but when you say size, number of elements. Okay, now let's look at how individual elements could be accessed. You can use index, for example. If you say print a note, which gives you the first number here, which is 1, right? You will get 1 because what we say, okay, access the first element in the n-dimensional array. Okay, I think that's all what I have for today's session.